Hello and welcome to my second video in the series, What Do I Need for Installation? Install accessories. In the previous part, we talked about power, and today we're going to discuss the signal path. It's like this. I have set up on the table. This is my joining radio. Set up on the table. This is my joining radio. This joining radio has a lot of options for outputting the signal. That's why I got it. And down here I have my Eaton DSP amplifier. And it also has a lot of options for receiving signals. That's probably a good combination to demonstrate, okay, how can we connect it everywhere and how not? Yes, I would say let's just get started. What options are there? Quite classically, when we have a factory radio, so not an aftermarket or retrofitted radio, but really the original radio that's in there. And then actually want to get music into our amplifier, into our DSP. So this here is our amplifier and DSP at the same time. I don't have a DSP here right now, but in the end, we can take the signals that we take from the radio. They go in here now, just like in the DSP. With a normal amplifier, we have a few specialties. I'll get right on that one, what is possible and what is not. I'm just going to grab an amplifier quick moment. Here I am. I got an amplifier. I'll place it a bit tricky over there. Can you see it? So, amplifier here. And now, let's start. What options do we have? Basically, when we're using the factory radio or even the entry-level radio and we don't feel like it, somehow to buy RCA cables or other types, then it's the case that nowadays most amplifiers, most digital sound processors, a few older amplifiers don't. It's worth mentioning about the so-called high signal. Can we feed? That means from the radio. No, that's wrong wiring. From the radio, we have here this ISO socket. And the ISO socket, it has speaker outputs. Usually that means we have it in the front. Left front, right rear, left. And we can connect these individual wires to most modern amplifiers and DSPs. It's really simple. We just take the wires that are basically in here. These wires we can, so once come out radio. This is the wiring harness comes of here. We can connect them here to what's called high-in. High-in, or here to what's also called high-in, A high-in, B high-in. That means we can also directly plug things in there. What does that bring us? What doesn't bring us? Basically, essentially, when we use the high-level output or using the high-level input, we have various advantages. We don't need a special cable. Count cables, we can just use regular speaker wires for that. We can connect any simple factory radio. That's all well and good. We also have relatively few problems with interference signals because the level is relatively high due to being high level. The only downside to this is really actually that, for example, with this Android radio, this, I'll call it cheap, China deal. It wasn't that cheap, but the good, Chinese don't fully achieve optimal sound from speaker output. They're not really giving their all to get the best and most audiophile sound out of the speaker output. What's up? This radio has amplifiers, and the amplified signal goes through all components. And accordingly, the signal that is already amplified, that is, the signal goes through all the components of this radio, including the final amplifier. What comes it isn't super great. That's why there are other options. Another option. Number one is very, very classic and has been around for as long as I can remember. And it's about what's called the low-level output. Low-level output actually means that before the signal is amplified in the radio itself. That means after the digital to audio conversion, we now have an analog signal. And now there are two ways. And either we send it out through the low-level output, or we go with it now. Amplify radio, handle low signal. We've just gone the radio amplifier route with the high-level signal, and now let's take the low-level signal. When we come out of the low-level signal, it's actually the case that we have here in the radio. We, front, right, front, left. We also have a subwoofer output. We also have more at the back, left and back right. Could you also use that? These are called RCA jacks. And for these RCA jacks, there are actually RCA plugs. That means I could take this cable and plug it in here. And now I'm basically going out before the amplifier of the radio, which of course is definitely better in terms of quality. And I have these two other ends here. And I can just plug these two other ends into my DSP amplifier like normal. That means in there. Boom. I've already established a connection between the radio and the DSP. If I have the connection like this now, then I'm happy. I'm pretty satisfied. All's well. And yeah, what does it bring me? So I definitely have, because I'm using the low-level output, I have a better quality. Because, as I said, I'm saving a few components from the radio and going directly into the DSP, into the DSP. And in the DSP, or rather in the amplifier, we also have, because if a high signal comes in there, they actually want to work with their low level as well. That means usually the high signal is compressed again and then amplified. That means low level is always nicer. The problem with no level is we obviously need appropriate RCA cables, but they also have to be shielded because we're talking about low voltage running on those things. Normally we have between 2 and 8 volts on RCA cables. At full scale, that means the voltage is relatively low. And in the car, we have quite a few interference signals that can play into it. Things like alternator whine can happen, right? That can definitely happen. Or any other light buzzing when you turn on the lights, any PWM signals that get mixed in or whatever. It's all there. It's not nice. It happens on these cables. This here is already a relatively high quality Deeds cable. It's actually quite a bit older. But I think it's from the Garben series. Yes, exactly. The Deeds of the cable are significant. Deeds triple shield. So triple shielded, that's something. That would be the method using RCA cables. I can connect this RCA cable here in a very classic way. To connect to my amplifier. This is also normal here. Pre in, pre out. Pre in, exactly as it is. Pre in A. 1, 2, done, connected, and be happy. Work. So I'll put those aside. Because now we come to other possibilities. To transmit sound, or rather the signal. Next, we just have a way to transmit sound digitally. Digital means we can sound through something called SPDIF. That's what the thing is called. That stands for Sony Philips Digital Interface. Yes, great. And through that, we can transmit information. The information we transmit there is digital, meaning zeros and ones. That means either it works or it doesn't. We just can't get interference signals in there. There are two possibilities to transmit that, and there is the option to do that with a coaxial cable. And there is the option to do that using a so-called toslink cable. The difference is relatively simple. This here is a coaxial cable, so it looks a bit like our RCA cables, just a little different. I got this here, and we can connect that here to the radio. And then we can plug that into our DSP on the other side. That usually doesn't work in amplifiers, because power amplifiers they don't have the processing power to convert digital signals. That is why the SPDIF signal only works with DSPs. Now this DSP, or the DSP amplifier, doesn't have a coaxial input. In my opinion, that's actually the better way to go, because power is also transmitted through this. That means it could be that the ground is being stolen from somewhere or something like that. That's why, for me, it's just a temporary solution. Better with an optical cable. An optical cable has a huge advantage in the car, that it doesn't pick up any interference at all. It doesn't pick up interference. And here, that's of course the big advantage of this joint radio, which is why I bought it. It has an optical output. It says here, optical output. That means I can connect my optical cable here. I can take the other end and go into the SPD input here. Done. I basically have now, still before the digital audio conversion, still before the digital to analog conversion of this radio, I send the signal through this optical fiber into the DSP. That means I get the best signal that this radio can somehow output. I get it directly here in the DSP. Light can't get interference, electricity transmitted, on, off. I have no way of getting interference in here, since no electricity is transmitted here either, but really just on, off. I also have no way of getting interference in here, so I could shine a flashlight in here. Then I might get interference, but otherwise there are somehow interferences from various things. No chance at all. So, using optical fibers is the best way to transmit sound for this combination. It can get better. Let's take this out and plug everything back in. Very important. With these SPDIF toslink cables, always work with them. Work with the protective caps here. The thing is, if dust or something else gets in there, it can definitely happen. That they don't want that either. That's why it's always good to do that when you can put the caps on. The next version we have to transmit sound is digital USB. That means there are power amplifiers. This one can't do that, for example, but there are power amplifiers from various manufacturers where it is so they can be connected directly via USB to radios. The radio here, for example, also has a USB output, and all these Android radios have the option available, or all these tablet conversions, to work directly with a USB sound card. That means you usually plug in a USB sound card, like a radio, and then it has some kind of output. It's just like connecting a USB sound card to a phone, another phone. Now there are DSP manufacturers who say, oh cool, then we'll build the sound card into our DSP. That means there is a USB connection from the radio to the DSP and the DSP, the sound card itself. That means it is actually digital, but at this point it's still one level lower. That means in the end the data goes into the DSP via USB, and that naturally provides the possibility that the DSP specifies the transmission clock, which helps to prevent jitter. And yes, that's just of a higher quality and is very much appreciated in the high-end sector. Then we come back to a feature that this amplifier also offers, at least part of it. And the thing is that DSPs, now not amplifiers again, but really DSPs, to offer streaming directly into these DSPs. That's not that old yet, but you can actually connect directly, whether it's from the radio. Theoretically, an Android radio could also establish a Bluetooth connection or a Wi-Fi connection, but it can also work from a phone or any other source. That means you can actually get into a car, just have a regular radio for normal music and so on, maybe through high-level connection or something like that. And if you want to listen to your high-end music, you can also stream directly into the DSP. That's how it is, for example, with this one, with the amplifier. It has Wi-Fi streaming built in. That means you can actually do it here. I believe a DLNA streaming connection is being established with a Wi-Fi here at this point. And when you connect the phone to the amplifier, then you have the option to stream all outputs from the phone directly into the amplifier. And as a result, depending on the codec, also a high-res option. Additionally, it's really convenient when my phone is connected to the DSP. I can also adjust all the settings. Yes, those were the 5 ways to transmit signals. I hope to have cleared up a few uncertainties. And yes, I'm glad you watched. The next part, it's about insulation. In the first part, which I'll link, we talked about electricity. In the second part here, we talked about the signal path. And the third part is now about installation for sound insulation to really make a car quiet. To make it quiet or to stabilize the recordings. Thank you for watching and see you next time. Goodbye.